Here, mathematical modeling example case studies we are going to study in this video. So, number of videos are there. Watch it on my channel Kadam Academy. And here, bicycle. See, this is the bicycle. This is a two-wheeler. That is a motorbike. And this car just quarter car. It's how the quarter car and how we can do the physical systems or these actual models into physical system in mathematical model. So, and what you learn after watching this video for this bicycle, two-wheeler and quarter car, after completion of this video, you are going to understand the introduction to physical mathematical modeling, and after that learn analysis vibration problems and steps to find out the replace the physical system by a mathematical model. What are the different steps you will learn? After that, the mathematical modeling for the bicycle or the two-wheeler, that is the motorbike, we are going to study here how to develop this mathematical model. Here, the case study of the mathematical modeling of the quarter car you are going to learn. On this slide, introducing the physical and mathematical modeling, you must learn what are the physical model and the mathematical model. Mathematical modeling from physical model of vibratory system we are studying here. So in real life, most structures and machine systems have elastic members with the dynamic system, hence have an infinite degree of freedom. Already we have studied in degree of freedom video. We can watch what are different type of degree of freedoms. For such vibrating system, physical system, the dynamic system for which the variables are there, that is the excitation and responses, and which are time based. These are time based responses and excitations are there in each vibratory systems. Okay. So response of vibratory system mainly depend on what? Their initial conditions and the external excitations. So these vibratory systems are very complicated and hence they are difficult to analyze, and to solve problem solving of such vibratory system are need to do analysis very properly. For that reason, physical system is converted by drawing mathematical model. Okay, so in engineering problems or various machines or the various whatever the machinery we are using, they are having infinite degree of freedom. So that problems maybe we can say when there is a infinite degree of freedom, that will be the continuous system, or we can distributed system with the complicated differential equation, and we have to replace that complicated equations into simple solutions with the solutions, simple equations with solution. These differential equations become accurate and we can solve and analyze that the continuous system, which is difficult to analyze, and hence they are generally analyzed by converting them into discrete or lump parameter system. So this procedure of modeling is same for all engineering fields. Okay. So, but the details of modeling varies with the field. Whatever the field is there, according to that, the modeling will be different. So we'll study in different video the different modeling system. Okay. What is the lump parameter system? We'll see now. In this lump parameter, helpful by considering or converting them into concentrating them into individual property of vibratory system. Individual property of vibratory system. To replace this physical system by mathematical model, different 4 steps are there. Okay. So these 4 steps I will show you one by one. The following procedure. First step is what? Conceptualization of the physical problem into mathematical model. We'll go in detail in this one. Second is the derivation of the governing equation of differential equation of motion. So this we have to derive the governing equation for this mathematical model, and this mathematical model were formed or drawn by using this physical problem or physical system. Okay, the physical model were converted into mathematical model, and were derived this governing equation or differential equation for this mathematical model. And now what, after this got the equation, solve the governing equation for a specific, what are the conditions are given, boundary conditions, or the what are the external forces are there, by using the various methods. Okay, and lastly, interpretation of that solution obtained in a step 3, and its application in design. That is the 4 steps. We study one by one. The steps of this vibration analysis of the vibration problem usually involves following steps. First is the conceptualization of the physical problem into mathematical model. That is the physical model going to convert into mathematical model. And here, what will happen in this step? This is a very basic step. Okay. While converting the physical system, mathematical system, its main purpose is to represent all the important features of the system for deriving the mathematical equations. The behavior of the system without making the complicated. The mathematical equation of governing equation, we get it by considering all its features. Mathematical model may be linear or non-linear. Here, decision to be taken whether the structure should be treated as a continuous, that means the multi-degree or infinite degree, or some standard degree, number of degrees. And with the advantage of considering the lump parameter system, means what? All the features were to consider of that system. With the degrees of freedom we have to finalize. And we will have the location of the lump masses. Also, the excitation causing it must be given. What are the excitations? What are the responses? How is the response due to this excitation causing? And that mathematically feasible form, that we have to just decide it. So what will happen then? That by using the Fourier analysis also we can solve this conceptualization physical problems. So here, this mathematical model may be linear or the non-linearity, with the equation that depends on the behavior of the components of the system. Means whatever the different parameters we are considering for that mathematical model, that is considered. Okay. So next step is what? Deriving the governing equation. Derivation of the governing equation or in the form of differential equation. This could be done by first principles of dynamics. It's based on this first principle of dynamics to derive the equations that describe the vibration systems. Both equilibrium method and energy methods can be employed for this one. So resolving the forces couple by drawing FBD, means free body diagram of masses, is considered, and equation of motion is derived by considering all the mass, inertia forces, reactive forces, or the external forces, etc. The choice depends upon the convenience of the resulting the analysis. Whatever the forces and masses are given, that will be, that system may be linear or non-linear, that may be discrete system or the continuous system, and according to that system we have to just derive the equation of motion. That equation, suppose the discrete system, that equation becomes the ordinary differential equation, or suppose in continuous system, that equation becomes the partial differential equation. Under this deriving this governing equation of motion approach, various approach we can use. We can use the energy method or this FBD energy method or the FBD or the equilibrium method we can utilize. Next step will be the solving the governing equation of specific boundary condition and external forces. Means what this in this third step, that will be whatever the surrounding problems while solving this problem solving in vibration system with the high degree of freedom and complexity is there in the system. Suppose to solve it by governing equation by using the various techniques are there, that Laplace transformation, matrix method, or numerical method. Like this, the various, considering this initial condition, we can form that utilizing these various techniques, we can solve that governing equation. For some complicated equation, computer programs are also used. For the calculation purpose, it is not possible and difficult to conclude the behavior of the system by using the that will be easier by using this computer programming. Okay, so response of the physical system is obtained by solving that equation, that is in step 2. So it may be necessary sometimes to use the transforms like a Laplace transform to solve the equation, or the multi-degree system harmonic solution for the each mass may be assumed to natural frequency determined by the matrix method also. Friends, last step is the interpretation of the mathematical this equation or results. Whatever after getting the solutions, these results or solutions obtained in step 3 and its application in design, and as a vibration as an applied science, results obtained after the solving the mathematical model equation of motion. The solution of the governing equation gives the suppose the displacement, the amplitude, we can say the amplitude, and after we can calculate the velocity. Similarly, we can calculate the acceleration, time period, frequency, natural frequency, different masses of the system can be found, and the analysis of vibrating system can be done by using the above results. So friend, like this we can solve the mathematical modeling equations. This mathematical vibrating system, before considering, already I have shown that lump parameters. So what is the lump parameter? Most of the structural machine systems have the elastic members. Okay, hence the finite degree of freedom of such system are referred to as continuous system or distributed system, and analysis of this system requires the complicated differential equations. So what will happen? This solution of this differential equation of complicated equations would give the accurate results. So however, the continuous systems are difficult to analyze, and hence they generally analyzed by converting them into discrete or lump parameters. In simple language, दोस्तों मैं आपको बताता हूँ. This continuous system means what? The infinite degree of freedom. Okay. For this purpose, this is the one of this part of that system. Okay. This part is converted into simple the discrete lump parameter. We can say the discrete system. This continuous system is having the multiple degree, but here only 1 degree of freedom. That is conversion of this mathematical model. While converting this one, it is useful. So this step is very important. As the name suggests, the lump parameter system concentrate the individual property of the vibrating system. Means last that shown you this this is the one rod. Okay, it is converted into spring mass system. Okay, that this delta is the displacement. So it is converted how these can say here this lumping property of mass would be considered that complete mass concentrated at the center of gravity, and on similar lines the property of elasticity can be considered by lumping the elastic responses. So what we have done here, we have just converted this system into simple this procedure of vibrating system replaced by the physical system and mathematical model. So by converting this continuous system into discrete system, just we have converted the physical system into mathematical model for the getting the solution. So like in this, that rod is considered with the property of elasticity with stiffness K and the mass of this lump property of the elasticity. Using this method, any practical system can be broken into various elements, thereby reducing the complexity of differential equation, and carefully development of the mathematical model would give the reasonable accurate solution. And here, see, this continuous system, if we write one equation for this system, so that equation may be difficult to solve, but for this system it is very simple. Differential equation will got it. Most of the elementary kind of the continuous system would be an elastic rod, that is the shown in this figure A. Okay, this figure A. This bar can now be converted into lump parameter system by concentrating the mass, this mass concentrated here at the center of this bar. An axially loaded bar, the axial deflection of the self weight would be given. So this K that will show it's a self weight. Okay, and this system is converted like this. This distributed one, the lump parameter system. So this del, how we can calculate for this continuous system elastic rod with the cross-sectional area A, modulus of elasticity E, and its mass is m. And how to find out this deflection del? By using this formula mgl by AE. That means the W into length of this elastic rod in denominator AE. How to find this K? We can find out W by del. That means AE by L. Here W get cancelled and AE by L is remaining. This cross-sectional area, modulus of elasticity, and length of bar, and that equation we can derive by for this lump parameter. Okay, so friends, now we are going to study the case study, mathematical modeling of engineering product like a motorcycle or motorbike. Okay, so in this one, the figure I will show you the real system, means the real motorbike that we have to convert into physical modeling. Only the most important features are considered in this physical model. This is the 2D diagram for this bike with the rider. Rider front means the spring mass system in front, and in the rear, okay, this wheel and this tire, that are only considered. The main important features are considered. To show this in this diagram, the rider, in this case the rider and the total bike, they are assumed to be integral part of the two-wheeler bike, and this rider, they are assumed as a integral part for the directly added to the mass of the vehicle. Okay, so that were considered here for physical modeling. After that model were converted into mathematical model like this. This model is converted into mathematical model. This one as shown in the figure B and the C. Okay, this figure A, and this deriving this mathematical model, we have to derive the equations by using this any of the principle like Newton's law or different laws are there. Energy method will be there. We can just get it the equation of motion of that mathematical model, and we can get it the solution for this natural frequency, amplitude, or the time period, or the mass we can calculate. But here what we have done, just get it the equation of motion, and that will like this, that mx double dot plus cx dot plus kx is equal to f of t. The f of t means what? The excitation. This road is not in this uneven road is there, and due to this uneven road, that will be create some excitation in the bike. Okay, so this type of the uneven road, that will be we have to for this excitation it is we have to consider. But what will happen here, that consideration of this solving this mathematical model in motorcycle, we have to convert this physical model. This is the physical model we have converted in mathematical model. Here what we have considered, this masses of the wheel, this mass of the wheel, we have considered MW. Here separately written here MW. Okay, and what we have done, this mass of the vehicle MV and mass of this bike, this total bike, okay, motorcycle, that we are already considered as a one integral part. Okay, here consider the MV plus mass of this bike. Okay, so here this spring mass system here consider for this rear and this rear and this front wheel. The struts are considered, both the struts are considered, and this tire and the wheel, they are considered, they having in the touch with this soil or the ground level, and here it is considered as a KT as a spring stiffnesses. Okay, this KT, why we are considering as the elasticity of the tire, the tire, and this mass of these wheels were also considered. So in this top side of this one tires, here is the spring and here is the damper, like this one. From this diagram also we can represent the damper and the tire. Similarly in front and in the rear also there is a spring and damper will be there in this system. So this physical system is converted into mathematical model. After solving this or just simplified it, this diagram is there. That is equivalent spring and equivalent dampers were just calculated, and very simple diagram, and it will represent this equation, and easily you can solve this equation and we can get it the solution of this equation, and we can find out the velocity, displacement, acceleration, natural frequency of this mathematical model of motorcycle. One more representation for this mathematical modeling of this motorcycle dynamic system, I will show you the struts. Struts means for the damper and the spring. The combination they are called struts. Strut system is shown to you like this, and this physical model is from this motorcycle. The motorcycle with the strut system shown to you, and this physical model is considering the rider, vehicle, and the wheels and struts. Okay, and that will be represented here in mathematical model with the different parameters, vibration parameters, riders weight, vehicle weight, and the considering the spring damper. Okay, vehicle also if we consider differently, this diagram will be represented. So two struts are there. Okay, two springs are there in each bike on the both the sides, and two dampers will be there, and front side and the rear side. The two dampers, two springs are there. Again there is in back side there are two springs and two dampers. Here that's why it is written 2 and this tire with this ground, they are considered as a spring. They will behave like a spring, and that system just converted into this system, and that is this simplifying diagram. And this simplifying diagram again we are simplified into this one. Okay, that means the total weight with this ground uneven displacement or the excitation will be here, and the total 4K and 4C, they are considered as a damping and the spring equivalent. Okay, equivalent spring constant and the equivalent damping constant here. And like this, the modeling of the dynamic system into simplified diagram model, and easily we can generate write the equation, derive the equation of this system, and we can get it the solution of that system, and we can get the natural frequency of this system or this bike for the various condition of the excitations. So friends, these are the diagrams. I just shown you the lump parameters. Already rear wheel, front wheel. Okay, already we have studied. So these are the rider is also assumed as the integral part and the two-wheeler. So this is the total study of this mathematical modeling of the motorbike. What are the outcomes of this video of mathematical modeling for this all the vibrating system? Write down 3 outcomes. And friend, here you always learn by self-assessment only, and you have to subscribe my channel Kadam Academy. If you are not subscribed, please subscribe it. Thank you very much.